Welcome to our teacher app. I am your math teacher. Today we are going to discuss about tangents and secants of class 10th. Now we are going to discuss about tangents and secants to a circle of class 10th. So this is a chapter which deals with the circle and its tangents. So before going to discuss about the main topics or main important formulae or important things in this chapter, first we should know what is a tangent and what is a secant. See, if you consider a circle, so now a line is here, Now both there is no difference or there is no relation between these two. So this is a circle we will call, that is called a line. Now when the line is moving towards the circle, what happens? See, this line is moving towards the circle. At one point, at a particular time of incidence, the line is going to, at the beginning, it will touch the circle. So at one point, it touches the circle, and as you keep on moving this side, what happens? The next step, the line will come like this, will come like this, will come like this, will come like this. Again at this point, just at the final stage, it touches or it have only one point of contact. After that, it leaves off the circle. So when you observe the movement of this line, what happens? At the beginning, the line is going to touch. So at the point, at the time of incidence, we will call this one as a tangent. So this one you will call it as tangent. That means tangent is nothing but having a point of contact, only one point of contact with the circle. And the next incidence, see, now it is having only at one point. Just if a fraction of second it moves, it will have 2 point of contacts, that is 2 point of contact the line will have with the circle. So a line which is having with the circle at 2 point of contacts, that is called the secant. So it is called a secant. So now how many secants? Infinite number of secants we can construct in the circle. Say inside the circle, wherever you take, when it have 2 point of contact, that is called secant, and when it comes at the last point, again this will be called as a tangent. So this line also is called a tangent. So tangent is nothing but having only one point of contact with the circle. So the circle is having the point of contact with a line, and a line is having 2 point of contacts. It is called a secant. Now with the help of these two, we can discuss so many different types of sums are so many examples based upon this one. Now, so if you consider the secant and the tangent, say now if you do not consider about this line, if you consider only line segment, see, this is called a chord. So such chords, infinite number of chords we can draw. Out of all the chords, the chord which is passing through the center is the longest chord, and it is called diameter of the circle. So and this is the center of the circle. This part is taken as a radius, and the entire part is taken as a diameter. So when you take a chord, suppose this is the chord, the circle will be divided into two segments. One is a major segment, other one is a minor segment. So with the help of the chord, we can divide the circle into two parts. Now if you consider about tangent, if you take the tangent, what happens? This is the circle, and if you consider this is the tangent. So now from an external point to the circle, we can draw 2 tangents we can draw. See, this is one tangent and this is the another tangent. So in this one, the first point is from an external point we can draw 2 tangents. And second point, see, for any circle from an external point, if you draw 2 tangents, the 2 tangents are equal in length. See, so now see, this is suppose if you take a P and this is the point A and B, so PA is equal to PB. For any circle from an external point, if you draw 2 tangents, both the tangents will be equal in length. And third point, how to construct tangents to a circle also we will discuss. So how to construct a tangents in this chapter for a particular circle we are going to discuss. So it is very easy. See, if you take a circle and they will give from a particular point of distance from the center, suppose 10 centimeters if they give. So what to do, the perpendicular bisector we have to take both sides. So this line will divide at most, that means this line is going to divide the given line into two equal parts. So if you take this one as the center and if you construct a circle through the 2 points, so you will get one more circle. So this circle is cutting at the 2 more points. So now if you join these two, you will get two tangents for a particular circle. So this is the way of constructing tangents to a circle. So these are the most important topics which we deal in this secants and tangents. And already we discussed about the segment. See, major segment and minor segment will be. So how to find area of the sector and the area of the length of the sector we will see. So now first one, the fourth point is about sectors we will discuss. So what is called a sector? If you take a circle and from the center, if you take two radii part, the distance between or the area between two radii is called, this is called a sector which is having an angle. So how to find area of the sector? Area of the sector formula is x by 360 into pi r square is area of the sector, and the length of the segment, see this is the length of the segment. Length of the segment L is equal to, we will get x by 360 into 2 pi r. So with the help of these two formulae we will do the sum. See, they will give the sums like this. See, if you consider this is the part, so how they will ask us to find, this is the shaded part. So they will ask us to find the shaded part which is given in the diagram. So we have to use compulsory either the area of the sector or area of the semicircle and area of the triangle. Different types of shapes they will give. So with the help of the different types of shapes, we have to subtract from the area of the circle. So that, see here, if we consider, we will consider, suppose for the example in the sum, this is called a semicircle. So first we will find a semicircle area pi r square by 2. From that we will find the area of the rectangle. See, in a semicircle, wherever you take the triangle, it is a rectangle, right angle triangle. So if you subtract from the area of the semicircle the area of the right angle triangle, we will get definitely the shaded part region. Such sums we will discuss at the last, at the end of this topic. So these are the main topics which we deal in this topic.